So now take this problem of problem 54 of your textbook. It says that a track shown in the figure, this is the track, the horizontal track, but there is a trough in between. The block B of mass 2m. This is block B, whose mass is 2m, is lying at rest. So it is lying with zero velocity. And the block A of mass m, this is the block A, whose mass is m, is pushed along the track. That means it may be pushed. It is pushed and then it follows the track. The collision between A and B is perfectly elastic. Good. What velocity should the block A be pushed? That means what should be the value of this velocity? They say this velocity u. What should be the value of u so that it just not it, I am sorry, so that block B just reaches the point C, so that the block B just reaches the point C. So B just comes here. Just comes here. Now, in your textbook, it's actually the problem is given in a different way. A man sleeping here, and so that the block B should go and knock this man and he should wake up. Anyway, to remove all that unnecessary talk, what we need to find out, what should be the velocity of u so that the block B just reaches point C. And at that time, block A may be somewhere here, somewhere in between. Now, we start this way. Let the required velocity of A, right? and velocity just before impact, just before collision. That means what I need to say, when block B was sitting here and block A just reaches beside this is A and this is B. The velocity of B is 0 and velocity of A towards right is say 1. This is just before collision. So we write before. Sure. This is the status just before collision. Then just from the kinematics formula, since this height is given as h, from the kinematics formula, we can find out. So u1 square is equal to u square plus 2gh, because the block A is falling under the gravity. Here we write u1 is equal to u square plus 2gh whole under root. This is one relation that you need later, right? Then let us say velocity of B, say velocity of B just after collision is equal to B. That means just after collision, velocity with this car, the B starts going up with a velocity, and this is B, block B, and block A also will start going up. Let's say its velocity V1. This is block A. This is after collision. After collision. This is after collision. In that case, we have said, say velocity of B just after collision is V2. And with this velocity and with this velocity of B and with this velocity, it just reaches the height, h. That is the question is given in the question. With this velocity d, it just reaches the height h. In that case, once again, from the kinematic equation, we know V2. I'm not doing that deduction because it's a very well-known formula to you by now. In that case, V2 is under root 2gh. Now coming to conservation of momentum. Conservation of momentum at the elastic collision. Conservation of momentum at the perfectly elastic collision says that the total momentum before collision. So total momentum before collision is mass m, mass of A is m u1 plus mass of B is 2m, but it was at rest, so its velocity is 0, is equal to, after collision, mass m multiplied by v1 plus 2m multiplied by v2. Right? From there we get all m's get cancelled, m, all m get cancelled. So here we get u1 is equal to v1 plus 2. V1 equal to V1 plus 2V2. Now V1 is V1 plus 2 and V2 is under root 2GH. Under root 2GH. From there we get 1 minus V1 is equal to 2 under root. Let us say this is equation. This is relation 2 that we have got. Also, now we consider the conservation of moment, conservation of energy. consider conservation kinetic energy. When we consider conservation of kinetic energy, then kinetic energy just before collision, the first body is half, first body's mass is m, and its velocity was u1 square plus half mass 2m, and its velocity was 0, will be equal to, after collision, half m v1 square plus half m v2 square, half 2m v2 square, half m v2 square. Once again here, all half and m gets cancelled. Half and m gets cancelled. This is 0 anyway. Half and m gets cancelled. Half and m gets cancelled. So what we are left with? We are left with u1 square. On the left hand side, we have only u1 square is equal to v1 square plus, once again, v2 square. v2 we have found under root 2gh. So v2 square is 2gh. From there we find square v1 square minus v1 square is equal to, okay, this is relation 3. Then what do we do? Here we have u1 square minus v1 square. Here we have u1 minus v1. So now we can solve it. What do we do? We divide equation 3. We divide equation 3 by equation 2. If we divide equation 3 by equation 2, equation 3 is u1 plus v1 and u1 minus v1. This was equal to 4gh, that is divided by, look at equation 2 is u1 minus v1, u1 minus v1 is equal to root 2gh, or we can write 2 under root 2gh. From there we find on the left hand side, this u1 minus v1 and u1 minus v1 gets cancelled. So what we are left with, u1 plus v1 is equal to 4 divided by 2 root 2 is equal to root 2. And gh by root gh is root gh. So under root 2 gh. So let us say this is relation 4. So we have u1 minus v1 and we also have u1 plus v1. So now we can easily convert this. We can easily find the solution to this. So now what do we do? We have equation 2 and equation 4. So what do we do? First we do equation 2 plus equation 4. If we do equation 2 plus equation 4, then we shall be on the left hand side, we shall be left with only 2u1. 2u1 is equal to plus root GH. So equal to 3 over 2 GH. Right? Therefore, U1 is equal to 3 by 2 into this is the value of U1. Now let's go to this relation 1, where this relation 1, where a relation between U1 and U is given. Here, there was a little mistake here. This 2 was not here. It was U square. It was U1 square equal to U square plus 2GH. So this is U1 equal to under root U square plus 2GH. This is from relation 1. So we write from relation 1, relation 1 is U square root U square plus 2GH, U square plus 2GH. That means from here we get 1 square. That means we get, let us write U square. From here we get U1 square is equal to U square plus 2GH, squaring both sides. So from there we get what is the required value that we need to find it. U square is equal to U1 square minus 2H. Now, 1 square minus what is U1? U1 we have already got. So U1 square is 9 by 4. That is, let me write it clearly. U1 square is 9 by 4 minus 2GH. 9 by 4 2GH minus 2GH is equal to 9 by 4 2GH minus 2GH. 9 by, so let us bring it to similar to this. 4 and 2 gets cancelled. This is 9 by 2GH minus 2GH. 9 by 2GH is 4.5 minus 4.5GH minus 2GH is equal to 0.5 GH. This is U1 square. So U is equal to under root 2.5 GH. The value, this is the value of the first block U, first block A, with this velocity, block should be pushed so that after collision, the block B just reaches the highest point C. That was the question. Okay.